So the interior and the exterior angles of each one of these polygons. Now I'll get one a review sheet. And one for myself too, as long as I'm at it. Although I think I've got all the problems copied down. First shape. What do we name that shape? Just for fun, by the way. What do we call that? Pentagon, 5 sides, okay. How do I find the sum? Now watch the language here, okay. Sum of interior. I do not have a blinky light. I don't have any light. This is strange. There we go. All right, we're good. We're good. Minor setbacks. So what's the formula for, so we got sum, find the sum of the interior and the sum of the exterior. Not each interior, not each exterior. You got to read the question, or you're going to make the mistake. Okay? What's the sum of the exteriors always? 360. There's no work to be done there. Sum of the interiors is done by taking what formula? By the way, in math sometimes we shortcut. Instead of writing sum of, we use the Greek letter sigma to represent that. It means sum of. You'll see that more in Algebra 2 eventually and pre-calc and stuff like that. But that sigma is a shortcut. It means sum of the interior. So it's kind of a shortcut. Okay? What's the formula for that? Yeah.
N minus 2 times 180.
Okay, so this is going to be 5 sides. 1, 2, 3, 4, 5 sides. So 5 minus 2 is going to be 3 times 180, or 540. It's a quadrilateral. We should know the sum for a quadrilateral off the top of our heads. What is it? What's it always for 4 sides? 360. This has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So what am I going to take times 180? What number times 180? 8 times 180, which is 800 plus 640, or 1440. You get those right in the review? I hope so. Yes? Again, the biggest mistake people make on these is they either forget to minus 2 times 180, or they find the measure of each. They take this divided by 5 now, and this divided by 4, and this divided by 10. That's fine if it says find the measure of each in a regular polygon, but that's not what this question asks. So always be sure you're answering what is being asked in the question. Find the value of x. There we go, much better. So this is kind of funky, but what are we measuring here? What kind of angles? We're measuring exteriors, which means they have to add up to what? 360. So I got 1, 2, 3, 4, 5, 6 x's plus 30 has to equal 360. There's my equation. Because there's 6 x's and a 30. And we subtract 30. I get 6x equals 330, which x is 55. Is that right? Okay. How about here? 1, 2, 3, 4, 5 angles in that one. We're measuring the interior angles. What do they have to add up to? Well, the sum, so we're first going to have to find the sum, right? The sum is the number of sides minus 2 times 180. That's what we just did. So that's 3 times 180, because 5 minus 2 is 3, which is 540. Now they know the sum, I just set up my equation. 60 plus x plus x plus x plus x equals 540, or 4x plus 60 is 540. Subtract the 60, I get 4x equals, what is that, 480? So x is 120. This is the actual test. Who's got 100% still so far? Anyone? Yay. Okay. Oh, you? Okay, good. Okay. Next one's a little trickier. Find the measure of each exterior angle of a regular polygon in which the sum is 5,400. Now, this was a tricky one. This is a tricky one because we have to work our formula backwards. I don't know how many sides there are, but I know the number of sides minus 2 times 180 is 5,400, don't I? Because that's the sum of the interiors. How can I solve that? Well, I can divide both sides by 180. It's an algebra problem. And 5,400 divided by 180 is 30. So n minus 2 is 30, but I have to add 2. So n, there are 32 sides. That's not the answer to my question. That's just figuring out how many sides there are so I can answer my question. Because the question asks the measure of each exterior angle. And each exterior is 360 divided by the number of sides. So 360 divided by 32 11.25 degrees. Exactly. Okay. Probably just ruined a few perfect papers there, but that's okay. 12 degrees. Close, but no cigar. Sorry. Thanks for playing. We have some nice parting gifts for you. So that's a tough one, but now that you've seen it done, hopefully you'll be able to redo it tomorrow, right? Now you've seen how it's done. Learn from that. Know how to do it tomorrow. Because guess what? Mistakes today cost absolutely 0. Mistakes tomorrow, more. Well, no, not your life. No. What is the measure of each interior angle of a regular polygon with 15 sides? Okay, again, we just need to find the sum and divide by 15. Or, so I have two ways of doing this. I could find the sum. The sum is 15 minus 2 times 180. So 13 times 180 times 180 is 2,340. And then divide that by 15. Because they're 15, got to remember to put the 2 back on. And you get 156 degrees each one. That's one way of doing it. Or, method number 2, since it's each interior, I could find the measure of each exterior. Because that's really easy. I don't need to calculate a sum because the sum is always 360 divided by 15, which is 24 degrees. But I know that an interior plus an exterior always has to add up to 180. So since I found that, I just take 180 minus 24 is 156. That's the measure of each interior. Okay? So you can do it this way, find the sum and then dividing by the number of angles, or you can do it this way by finding the measure of an exterior and subtracting from 180 to find the measure of the corresponding interior angle. Either method works. You don't have to do both. Just choose one that makes most sense to you. This one isn't that much work. I mean, they're about the same. All right. Got a fancy picture here with a parallelogram. We're going to find AD and the measure of angle B. So notice we're not just finding the value of x and y, but in order to find AD and the measure of angle B, I'm going to have to find the value of x and y, aren't I? So let's start with x. X should be pretty easy. What's the equation to look like to find x? What am I going to do? Add those two together, set them equal to 180. Add them together, set them to 360. Add them together, set them to 90. Set them equal to each other. What am I going to do? Yeah. Equal to each other because they're opposite sides in a parallelogram, which means they're congruent, equal measure. So x plus 21 equals 12x minus 1. Do the algebra. I get 11x equals 22, so x equals 2. If x equals 2, then this is 2 plus 21, or 23. So AD is 23. How about the y's? What am I going to do with the y's? I'm going to set those equal to each other? Well, if it was a rectangle, I could, but is it a rectangle? No. So what am I going to do with the y's? Yeah.
Add them equals to 180.
Yep, add them to 180. So y over 2 plus y minus 9 equals 180. Okay? Now it's a little trickier, isn't it? It's a little trickier. But we can make this work. We can make this work. I'm going to add the 9 to each side. The algebra is a little trickier here. Y over 2 means 1/2 y. So this is 1.5 y, or 3/2 y, equals 189. And I divide both sides by 3/2 or multiply both sides by 2/3. So there's a little bit of algebra stuff going on here with fractions, because 1/2 y plus 1y is 1.5 y. If you want to do on your paper is 1.5 and divide 189 divided by 1.5, you can do that too. It's got to be a little more careful. But 189 divided by 3/2 is 126. Y equals 126. And a measure of angle B, well, B is going to be the same as D. D is 126 over 2, which is 63. So this is 63, so this has to be 63. There's a bit of algebra set up there. And when you get to a problem like that on test, make sure you show your work. Because if you make a little mistake here in the algebra setup, but you show me that you set it up and set equal to 180 and just make a little algebra mistake, you're going to get probably at least half credit for that. Just set it up correctly. But yeah, we are going to be giving you a little bit more challenging algebra concepts second semester, just because we are tuning most of you up for Algebra 2. Okay? Let's put our phones away. Leave them away. Vertices of a parallelogram are D, E, F, G. Give you 3 of the points, find the 4th point. This is actually a really simple one as long as you graph it. And by the way, there wasn't graph paper included here. You're always welcome to take a piece of graph paper and use it with a quiz or a test, okay? So if there's not graphs actually on the test, just grab a piece of graph paper off the back table, work on it, and attach it to your test. That's always okay. All right? So let's plot our points. D is at 5, 2. E is at 2, 6. F is at negative 8, negative 3. And it wants to know where G is. So we always go around in order. So D to E, E to F. Now G's got to be down here somewhere. But again, this is just pretty much just like finding slope, but without the formula. We just do it by counting boxes because we got a graph. Look, from E down to D was down 1, 2, 3, 4 over 1, 2, 3. Right? So I just go down 4 and over 3. And that must be, and if I draw it especially, I can really see. Yeah, it looks like a parallelogram. And let's find the coordinates of that point. It might, well, a rectangle is a parallelogram. Welcome to chapter 7. Okay, so this is at negative 1, 2, 3, 4, 5, 6. Negative 5, is it? Negative 1, 2, 3, 4. Negative 5. Hold on. Negative 1, 2, 3. Negative 5. Negative 1, 2, 3, 4, 5, 6. Negative 5, negative 7. Those are the coordinates of the point. Okay? So the graphing is definitely the way to do it. And it does kind of look like a rectangle. I'm not sure it is. I'd have to find the slope of the sides to find out if it's a rectangle, right? See if that's the right angle. Here's the one that always gets people. We got you on the homework. A lot of people had hit you on the quiz. So let's take a look at it again. Again, these are like when we're going to continue to see problems like this, and they're like puzzles. And one of the things that can make the puzzle a lot easier, go ahead and just start figuring out what you can figure out right away before you even start answering the questions. Okay? It says it is a parallelogram. It does not say it is a rhombus or a square or a rectangle or anything other than that. It tells you it is a parallelogram. So, can I assume that this SU is the bisector of angle TSB? Yeah. Is that a bisector and a parallelogram? Do diagonals bisect angles in parallelograms? Yeah. No. Only if it's a rhombus does it do that. Okay? So it cannot assume this 57 is divided equally into two spots here. Can I assume that this is a right angle right here? Angle W, is that a right angle? Nope, not in a parallelogram, only if it's a rhombus. Okay? So we have to be very, very, very careful in what our assumptions are as we're working on this. All right, so what do we know? I know this angle is 57, which means the opposite angle must also be 57 degrees. How about this angle then? What's this angle going to have to be? 123 degrees. Okay, and this angle is going to have to be 123 degrees. Because consecutive angles are supplementary and opposite angles are congruent in parallelograms. I know that if this is 123.8, then this must be 123.8 over here. Okay, if this is 108.8, then this must be 108.8 there. Because again, the diagonals do bisect each other and the opposite sides are congruent. And from here we can start answering our questions. TS is 123.8. SW is 108.8 centimeters. Measure of angle SVU we got is 123 degrees. STU is 123 degrees. US, the whole thing, we're going to have to add them together. That's 217.6. And TUV is 57 degrees. That's all we could figure. I mean, I've got everything figured out I can figure out there. I don't know the length of these sides. I don't know any of these angles. I don't know what the half angles are. But I found everything I could, and when I found everything I could, those are the answers to my problems. Okay? But you have to pay very close attention to what you're doing, because this asks for US and this asks for SW. I get a lot of people who ask for US and they give me UW. Okay, make sure you're answering what the question asks. Find the values of X and Y that make the shape a parallelogram. Okay. Well, I can set up for either one. Which would you like to set up for first, X or Y? Y is probably the easier one because opposite angles are congruent. So 62 equals 3y plus 2. When we do our algebra, 60 equals 3y, so y equals 20. And what about, and 62, now actually there's a couple different ways of doing this here. A couple different ways of thinking about for x. I could say, oh, if this angle is 62, these two angles have to add up to 180, so this has to be what, 112, 118, right? So I could say, I could figure that and then go 118 equals 5x plus 3, so 115 equals 5x, so that's 23. Or I could have done 62 plus 5x plus 3 equals 180, and I get the same result. Okay? So we got to know our theorems, obviously, about do the angles add up to 180, are the angles congruent? But again, guys, if you just slow down and think about this for a minute, it's not that bad. Obviously, these two angles are not congruent. One's acute, one's obtuse. So usually when it's one acute, one obtuse, we're adding them together, that's going to be a 180. Right? So it's not hard to figure out. How about on our diagonals here? In a parallelogram, the diagonals do what? They bisect each other. Don't just say the diagonals bisect. Diagonals bisect each other. So 3y plus 9 equals 2y plus 16 is my first equation, and 10x minus 24 equals 5x minus 4 is my second equation. And we just do the math. Minus 2y minus 9, y equals 7, and minus 5x plus 24. I get 5x equals 20, so x equals 4. Again, as you're doing this on the test, show the setup of the equation every time. Because if you make a mistake in the algebra part of the way through, you're going to at least get partial credit for setting up the equation correctly. Algebra mistakes are going to happen. We try to avoid it, but they're going to happen. But if you show me you understood the underlying concept by setting up the equation correctly, then we get the points. Show the quadrilateral is a parallelogram. Prove it. Gosh, you've been through this a few times. Negative 4, 4. B, D is at 6, 6. F is at 7, 0, and H is at -3, -2. It says show that that's a parallelogram. Well, how could I show it's a parallelogram? All it wants is parallelogram. I could find the lengths of all four sides, show the opposite sides are congruent. I could find the slopes of all four sides, show opposite sides are parallel. Parallelogram, I could find the midpoints of the diagonals. Oh yeah, that's the easy way for parallelograms, isn't it? So I could say midpoint, remember we're going to say what we're doing. Midpoint of BF equals -4 plus 7 over 2 and 4 plus 0 over 2. So that's 3 over 2 and 4 over 2 is 2. Midpoint of DH, sorry, my writing is terrible up here right now, is 6 plus -3 over 2 and 6 plus -2 over 2, or 3/2, 2. Same, so diagonals bisect each other. That's a parallelogram. So what are we finding? What's the conclusion? What's the reason? Okay? So you got to say what you've describe what it is you're measuring, show the work for the measurements, state the conclusion. Be thorough in your explanation. All right? Whoa! F just moved 7, 0. Back. I meant to draw lines there, okay, for the picture. I don't think I drew that right. I think I got a coordinate off. Well, what did I do? 4, -3, -2. It looks funky, but oh well. The math is good. Classify the quadrilateral. Give the most specific name. This is a rhombus. Why is that rhombus the best name for that? Yeah. 4 congruent sides, but does not have 4 congruent angles, right? It's not. It's got the same information. Okay. What is this shape? This is not a trapezoid. What do we know? What's going on? What's the given information telling us? It's telling me that all 4 of these halves are the same, which means the diagonals bisect each other, making it a parallelogram, but the diagonals are also congruent, making it a rectangle. It is a rectangle. Okay? Because the diagonals are bisecting each other and congruent. Diagonals bisect each other makes it a parallelogram. Diagonals congruent makes it a rectangle. Is it a square? Perhaps, perhaps not. We don't know. Rectangles as specific as we can get. How about this one? Square. Because all 4 sides are the same and the angles are right angles. That makes it a square. All right, ABCD is a rhombus. So now we know the diagonals do what? The diagonals bisect not just each other, but also the angles. And the diagonals are perpendicular. So I know these are right angles. So if this is 20 and this is 90, this has to be 70. Okay? And this has to be 20 here. And these two have to be 20s. And all these have to be 70s because it's a rhombus. Rhombuses are special. And this has to be a 4 also. Now I can answer my questions very easily. Find the measure angle BCA. And don't be afraid to do this with your pencil. BCA is my first one. Oh, that's obviously 20. CDA. So CDA. Oh, 70 plus 70 is 140. And AC, the whole thing, AC, that's going to be 4 plus 4, or
8.
Very good. So notice how that's different from the parallelogram. The parallelogram, we couldn't make these assumptions that these are angle bisectors. But in a rhombus, we can't. Because that is a property of the rhombus, just not of a parallelogram, yeah. BCA? Because the diagonals, the opposite angles have to be congruent, right? And since they're each being bisected by the diagonal, if this is 20, then all 4 of these are 20s. Well, 20 plus 90 plus 70 is going to be 180 again. It does work out, but I don't have to add things to get to it, no. I could also have used alternate interior angles here to get that, because of Z, right? There's a lot of ways of getting there. Determine whether given points are a trapezoid and whether or not it's isosceles. Okay, because we're running out of time, let's just say you're going to have to find the slopes of all 4 sides to show one pair of sides parallel, one pair of sides not, and then use distance to show that the non-parallel sides are congruent. So you have to draw it, figure out what are the parallel sides, what are the non-parallel sides, and congruent. 6 measurements. If anyone got this wrong, just go home now, because 9 blank 11. What number would go in the middle of 9 and 11? I'm thinking 10. Oh. I looked at the wrong one. Okay. 12 point. Well, if it's 12.2, that's a little tougher. Okay. But it's just 9 plus 12.2 over 2. Okay, 10.6. Well, the way I did it, 9 blank 11, would anyone get it wrong? Okay, good. How do I set this one up? Again, top plus bottom, or side. So 5n minus 2 plus n plus 8 over 2 equals the 2n plus 11. Combining terms, 5n plus n is 6n. Negative 2 plus 8 is plus 6 over 2 equals 2n plus 11. Now, be careful. I don't just cancel this 2 with the 6 or 2 with the 2. The best thing to do here is to get rid of it by multiplying through by 2. So 4n plus 22 equals 6n plus 6. And then we do minus 4n minus 6. And I get 2n equals 16, so n equals 8. But again, if you can at least get this set up with the equation, if you make a mistake in the algebra, okay, not great, but we can work on that. Get the equation set up properly. Finally, our kite. Gosh. What do we know? Which angle is going to be, are A and C going to be the congruent angles, or B and D? B and D, so this is 120, okay? And what do we know about the 4 angles of a kite? They have to add up to, 4 angles of any quadrilateral add up to 360, 240, 120, 70 is left. Okay? So there we go. Didn't really get through the entire trapezoid problem, but we've done a lot of those. Got to show your work, 6 equations to show that's isosceles trapezoid. Got to prove one pair of sides is parallel, another pair of sides is not parallel. You do that all by slope for trapezoids, and then the non-parallel sides are congruent. That's distance. All right. We'll see you tomorrow for the real deal.